Okay, let's see. Get started here, but got some music. That'd be helpful. That'd be helpful.
Under the moonlight, bounce up like the party people. Love what me, I don't know why. Do you understand this move to make everybody's watching me? Monkey dance like a star. Shake your body, dance on the monkey dance. Let's be together on the floor, baby. Monkey dance like we can. Move your body, dance on the monkey dance. Look at that girl into the rhythm. Bounce up like the party people. Love what me, I don't know why. Do you understand this move to make everybody's watching me? Monkey dance like we can. Move your body, dance on the monkey dance. Look at that girl into the rhythm. I'm hopeless in the crossfire.
All right, hello, everybody. Hello. Hey, Sneaky Weasel, how we doing? Gomash says, ask and redeem a question. How are we doing? You can ask a question anytime, Gomash. It's fine. How we doing today, everybody? I hope we're doing fantastic. Good to see everybody here today for another rip-roaring Math 120 alas thing that we're doing, apparently. Well, yes, you answered your own question there, Gomash. You didn't need to ask me that. How's everybody doing today? How's everybody doing today? I don't know. H? 1H? You mean 10? That's good. Tired, tired. Yeah, I know it's the end of the week. End of the week. Thursday being the end of the week, technically, for most of us. I know we're tired today, but you know we'll get through it today. Get a section and a half done. We'll bang it out, and we will keep moving forward here. That's the goal. That's the goal. Get a section and a half done or so. Get it all done. Get it squared away. Move on with our lives. There you go. Easy peasy lemon squeezy. At least I hope so. It shouldn't be that bad. It shouldn't be as bad as you think it is. I hate not sleeping. Me too. Me too, Gomesh. I hate not sleeping. You need sleep in your life. Get nice and refreshed and relaxed. Then as you get older, you wake up, you feel a little bit more tired. You're like, I need more caffeine in my life. You know, need to pick me up. You know, need a slight pick me up there. It's very important. Get refreshed and relaxed. Actually, I need to turn that music down. Pretty loud. Turn this down. Go. I don't drink coffee. I know maybe you're a little young for coffee. Eventually, you'll probably make your way out to drinking tea or coffee. Most everybody does at this point. Like, I'll never drink tea or coffee. Like, yeah, you know, that's a complete lie. You'll get there someday. The entryway is just first starting with energy drinks. Yeah, you see, you talk about energy drinks, and then energy drinks just turns into tea and coffee afterwards. Now I drink it a lot. Exactly, Sneaky Weasel. Exactly. Yes, it's kind of like a... Yeah, people, they go Monster, then you realize that Monster energy drinks are just like hot garbage. And you can get a lot better from a tea or a coffee. And it's a bit cheaper. I only drink hot chocolate. I don't like tea and I don't like coffee. I understand. I used to do the same thing, Goldmash. Used to drink only hot chocolate instead of tea and coffee. Eventually, I made my way to tea and coffee. Comes with time. Right now, it's hot chocolate, but I guarantee you that hot chocolate will be put to the wayside as soon as you need more caffeination. Chocolate only provides so much burst of energy. Tea and coffee is like a... How would I put it? A tea or a coffee is like... Because it has more caffeine, it's more of a sustained energy than a hot chocolate. And a hot chocolate's like an injection of a little bit of sugar. But if you're talking about a sustained energy, then instead of having a crash of sugar, like you get a big injection of sugar and then you crash, then you have the caffeine, and that's a little bit more sustainable over a longer period of time. And that's why you switch to tea and coffee, because that's what you need in order to be productive throughout the day. That's the important part here. The length of productivity is important. Alright, we're gonna get started here in just a few minutes, ladies and gentlemen. We'll get started in just a few minutes. We'll get moving on new stuff. This new stuff needs to happen. It needs to happen today. It needs to happen today, this new things that we do. When did I switch from hot chocolate to tea and coffee? Probably when I went to Japan, technically. I needed to walk around. I needed a longer energy trip. Like, oh, tea is a lot better. Don't have school until next week? Do you have holiday right now? The school holidays and stuff like that? Are you feeling better, by the way, Golmash? You don't have a cold anymore, I hope. Or if you're still coughing and sneezing. I don't know. That was a couple days ago, so... Okay, give another minute, and then we'll get started here with the newest material. You have 2-week October holiday? Okay, cool. Yeah, we have a, we'll have a November, here in the States, we have like a short midweek Thanksgiving holiday in the 3rd week of November. So, November we have a short holiday, and then there you go. I'm only coughing at night. Okay, that's good. That's a lot better than what you felt like last week, Wilmash. Let's be honest. Last week you sounded pretty miserable, so at least you're only coughing at night. So that's a good improvement. So I have to ask Sneaky Weasel, if there's a particular brand of coffee or tea that you drink. I don't know what kind of coffee or tea that you drink, if there's a particular type or particular brand. Alright. Okay. Gonna go ahead and get started here for today. Move this thing. Here we go. Hey, Beast! Because I work at Starbucks, I get a free pound of coffee each week. Okay, that makes sense. How we doing, Beast? I hope you're doing good, my friend. Alright, let's do some intros, ladies and gentlemen. And let's get started. Alright, let's do some intros. Is it okay if we go over this problem from the 8.2 homework? I can, if you're doing that probability there, I'll show you in just a second here, Victoria. Okay, let's go ahead and do this here. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So, ladies and gentlemen, today we are going to be continuing to move on here in chapter number 9, okay, talking about confidence intervals. But first and foremost here, I see a question here from Victoria regarding one of the 8.2 homework assignments. Alright, so just remember here that if you're going to do a problem like that, is what's the probability between two percentages, for example, that do or don't own a credit card, then all you have to do is, let's go to the big board here. Let's talk about that really, really quickly. Really super quick. Oh, Beast Hibba, thank you very much for the follow. It's good to see ya. Good to see ya, Beast Hibba. All right, now I got both of you guys. Yo, how's it going? All right, Victoria. So the way you want to do this here specifically is you're gonna do the normal CDF function here. All right, you're gonna do this normal CDF function. You're gonna put the lower percentage here first, in decimal, of course. So, let me give you an example here instead of just lower. You gotta put 0.37, okay, and let's say you have 0.39. All right, so 37 to 39%, just as an example there. How we doing, Hibba? All right, and let's say our percentage here happened to be 42%. All right, then don't forget your P here has to be very good. We're gonna put 0.42 times 1 minus 0.42, and then divided by whatever sample size they gave you. So let's say they gave you a random sample size here of 50. Okay, just whatever. Then this is all you have to do here, Victoria. I don't know what numbers that you have for that particular example, but that's the thing there. Jasmine, hi, Professor Chips. My car broke down in the middle of the road. Oh, jeez. All right. So, Jasmine, stay safe first and foremost. If your car broke down in the middle of the road, please stay safe first and foremost. Make sure you call for help, or you have somebody there that you know with you, so that way you stay safe. Okay, so that's the first and foremost important thing. And hopefully you can get your car fixed afterwards. But safety first. Okay, safety first, number one. I'm good, Professor. Yeah, I'm doing great. I'm doing great, Hibba. I'm doing absolutely great. If you've called Jasmine, I hope you've called a tow truck or at least emergency services, or maybe you've called a family member. Just call someone that, you know, at least you can get that situation taken care of. Totally understandable, though. I'm sure I'm gonna experience that myself. Oh, it's not too bad. I don't know how cold it is out there. Maybe compared to where you're at, though. Alright, is there any questions about that? Any questions about that, Victoria? Now that's essentially how you're going to deal with these problems here. You'll put the lower percentage, the upper percentage, the mean, and then you just have to, whatever those numbers are for that problem. Again, don't forget that standard deviation has to. The learning right now is beyond freezing. Well, how cold is it, Beast? How cold is it? I don't know. You have to tell me. We just need a tow truck now, but I'll hop in later. That's fine. That's fine. Just stay safe. 12 degrees? 12 degrees? Sheesh! So super easy. 12 degrees is easy. Feels like minus 10. I think it only feels like minus 10 because you're not used to that kind of temperature shit. Now, Beast, I gotta admit, we're from Chicago. 12 degrees Celsius is pretty easy to deal with, okay? 12 degrees Celsius from Chicago is like, okay, that's not too much of a problem. I know you're not used to it, that's the thing. Here from where we're at, that's not a problem. So it's like 54. So for those of you not sure, that's 54 degrees approximately over there in London right now. So 54C or 54F, sorry. 12C is 54F, guys. So he's complaining about the fact that 54 degrees is super cold, but especially when he comes from a country that's nearly 90 to 100 degrees Fahrenheit all the time, just to put it in context. All right. Okay. Now, you got 100 degrees every day? Yeah, no thanks. Yeah, the temperature difference, right? So it's the same thing as if we go down to like Florida, right? In like December, and we just say how ridiculously hot everything is. By the way, in December I might come to England alone again. I may come to hashtag. Oh, good. Well, I'll be there, Beast, in December. By the way, so you possibly could. All right, guys. We do have to move on here with chapter 9. Now let's talk about stuff we discussed here last Tuesday. Okay, so last Tuesday, not Tuesday, last Tuesday, this Tuesday I should say, last class. Last class we talked about confidence intervals within chapter 9. Okay, so we talked about specifically here, and I want to kind of focus on here. We discussed about, okay, how do we find a confidence interval? We said, all right, we are 95% confident that the proportion of all adult Americans who think TV is a luxury, in our example here, was between two particular values. We found that here via the calculator. All right, now we're going to kind of start off with that example here once again today. All right, and we're going to kind of work our way up here into finding a few more confidence intervals with a slightly different context, okay? All right, so let's go to the book here for just a moment. All right, so bring up the book. All right, and we're going to go ahead and bring up a question here. All righty. So let's take a random look. We're going to look at one of these questions here. We're going to solve for it. All right, and at least get ourselves up to date here. All right. So, number 31. Okay. 31 says, in a survey conducted by the marketing agency 11mark, 241 of 1,000 adults 19 years of age or older confessed to bringing and using their cell phones every trip to the bathroom. Confessions including texting and answering phone calls. Alright, I'm going to change this up a little bit. Let's construct and interpret a 90, let's say a 98% confidence interval for the population proportion of adults 19 or older who bring their cell phones every time they go to the restroom. Okay, let's do it. Okay, so our confidence level here, I'm going to change here. I'm going to change to 98%. Alright, so I'll put 98%. We'll use 0.98, of course. Okay, now, we do have a survey here. We surveyed some people. We said, alright, hey, can you tell me how many people said yes to my question out of how many people I surveyed? So if you recall here, if you just look at the question here, how many people said yes to my question? Well, 241 people said yes to my question here. Did I fit the survey? Do you take your phone every time you go to the bathroom? That's a great question. I mean, I ain't gonna lie. It is a good question because it's a relevant one. Dylan. I just put a poll for that. I think it's a fair poll. It's a fair poll, Dylan. So you can mark it. I put up a poll there in the chat. If you go to the bathroom every time you go to the bathroom, you bring your phone with you. Yes or no? I have a sneaking suspicion I know what the poll is going to say though. Gladys says yes. We all know what Dylan does. Ouch, Beast. Hmm. Good people, says Dylan. Yeah, take your phone with you. I'll mark my response as well. Oh, I'll just tell you my response. Watch Professor Chips. What else can you do? I don't know, Dylan. I'm pretty sure there's lots of things you can do. uh, if you don't, that's a lie. True. True. I voted as well. So, I'm gonna probably say that everybody in this chat probably takes their phone to the bathroom. I think if we think about it this way, right? Yeah, 100%. All right, that's exactly what I thought. All right, so if you think about it this way, this question is rather old. I mean, I think if we asked this question maybe I don't know 5-10 years ago, maybe there's gonna be a little bit of a difference. I believe though, um, I reckon there's 100% confidence level. I reckon there's 100% confidence level. I'm pretty sure that probably, realistically, Dylan, you probably could say that it's probably like 80-90% now compared to like 5-10 years ago. You know, where if you had the old school flip phone from way back in the day, definitely this would be much lower because there would be no point. There's nothing to really do on a flip phone, but you know. But asking today with more smartphones and more apps and more interactivity on your actual device, yeah, then you could say this is going to be much higher. But I'm pretty sure there's still some people who probably would say no to the question for whatever reason. They have their own reasons, certainly. Um, Hadi, I'm watching what you're saying. Yes, yes, Hadi, you have to be. Look, hey, Bazantu, there you go. All right, so here we have the number of people who say yes is 241. Now, the number of people surveyed in this case happens to be 1,000. So, what do we do here in this case? Let's talk about what we reviewed here last time. So, in this case here, we want to go ahead and use our calculator here for this one. Let's do that. We want to get a confidence interval here that will work. All right, and so remember that we want to go ahead and hit the stat key here. Let's go over this together one more time. Put it into the stat key. We'll go over to tests. All right, now remember that we are using the specific function here on the calculator of one prop z int. Okay, so int for interval. Okay, so that's going to be letter A. All right, so make sure to use the proper one there. And so we're going to use X here, which is the number of people who said yes in your survey. In this case, 241 people said yes to this question out of 1,000 that you surveyed. And your confidence level here, I just changed that up to 98%. So I know it said 95 on the question, but just change it to 98 just for the sake of this example here. And we'll calculate it out. All right. And so here we can get 0.20954, and we get here 0.27246. All right, so this is going to be our confidence interval at the end of the day. And we also discussed that there's a margin of error, so we can also use, again, remember that we can use this P here. That's going to be our point estimate, kind of like right smack dab in the middle. And then we can, again, find our margin of error, exactly how big the margin of error is going to be. Because, again, talking from 1,000 people and extrapolating that to an entire population certainly will involve a large margin, a margin of error of some variety. Could be large, could be small, just depends on this. Just depends on how many people you survey. And so 241 happens to be our point estimate. So let's say we take 0.241. We want to find our margin of error here. All right, so that's 0.241 minus, we could take it subtracted by the lower amount here, 0.20954. So let's do that. 0.241 minus 0.20954. So here we get our margin of error here is 0.03146, i.e. 3.15% of a margin of error based on our thing here. Hadi says, say something nice. Hadi, you are a very valued member of this community. Yeah, and you are an extremely loyal guy. You have a wonderful girlfriend in Hiba, and I think you will continue to do absolutely wonderful things. And I hope you have an absolutely great time while you're in London. I hope to see you at a hashtag game very soon, Hadi. That's you bring a lot of positivity to this community. Thank you so much, Hadi. All right, are there any questions about that so far? Any questions? All right, now let's work a little bit backwards. Okay, so let's say, for example, here, I want a particular margin of error to happen. Let's say I want a particular situation to happen. So let's go over this here. Get this out of the way. Okay, so now we have again. I just gave you an example here from what we discussed here last time. Now let's talk about finding a necessary sample size. So let's say, you know what, I want to give a survey, but I need to know how many people I need to ask in order for certain predictable results to happen. This is if you want to say, hey, I want to have a margin of error that's like 2.5%. Okay, I want to have, again, a particular, I want to ask X amount of people just to be sure that I'm getting accurate results. And then you can compile them and then put it together into whatever report you want to. Now, in this case here, let's talk about it. We are actually going to encounter two cases here if we're going to find the necessary sample size, i.e. say the number of people we want to ask our particular survey question to. Let's talk about those cases. All right, case number one is if P is given. So let's say your point estimate P here is given with a margin of error. So let's say you want an expectation with a margin of error. Then, now, I'm going to point out a couple things here first and foremost. So we have n here is equal to p hat times 1 minus p hat times this, this funky looking thing is z sub alpha over 2 divided by e. Now, exactly what are these things equivalent to in words? We can see that the sample size here is equal to p times 1 minus p. This z of alpha over 2, this is the notation here for the critical value. I'm going to elaborate on that as soon as I'm done explaining this, these two cases here. So there's a critical value that kind of goes with this, and a margin of error, and that's the E that we see down here. So that's the notation for that. All right. Now, that's the first case. The second case is if we're not given a point estimate P. So if we're not given a point estimate P, then we kind of settle for somewhere in the middle. We say, okay, if a point estimate P is not given, we don't know exactly where to start. That's fine. With some expected margin of error, then we just kind of rough guesstimate it. We say the sample size should be 0.25 times the critical value divided by the margin of error quantity squared, just like the last one was quantity squared. I think I forgot to mention that, so I'll just mention that now. All right. And so we just, the reason why it's 0.25, by the way, is because we just kind of 50-50 it. So that's essentially what we do here. Yeah, quick question. Go ahead, Connor, my friend. Absolutely, go for it. If you have a question, please ask. Be more than happy to answer for you. I announced that last time, Connor. So your test is due next week. Oh wait. Oh, this is hey, this is that's not 102. Sorry, I'm getting this confused. Yeah, November 2nd. That's right, November 2nd. I have yours as a little bit later. Sorry. So I announced that last time. November 2nd is when that's due. Right. Everything for chapters 5 through 8. Yeah, 5 through 8 is due November 2nd. I'll need to send out an email regarding that, so I'll do that, Connor. Probably after class. I'll send an email to everybody to give a reminder. Um, is MOE the point estimate here? The lower answer from our calculated answer? No. MOE is literally stands for margin of error. So you can think of point estimate here as like your thing in the middle. So I'll just put the differentiation here in chat. MOE is always a margin of error. The point estimate here is the value in the middle of the confidence interval. Okay, that's kind of like our starting point, and then we add the margin of error to the right, and we subtract the margin of error to the left in order to get our confidence interval that we get at the end of the day for these type of problems. Okay, now let's talk about the critical value. There is a critical value that we do need to discuss here really quick. I'll get to that in just a second, Alyssa. I just need to finish this up here. So if you give me just a little time. All right. So note here. Let's talk about the critical value that we can find here in both cases. We find that we have major critical values here at the 90, 95, and 99% confidence levels here. And this can be found in the textbook here on specifically page 396 of the textbook. I would suggest probably writing these down for your own personal notes. This can be extremely helpful, so you know exactly what to plug in, say, the calculator here. All right, so we do have these critical values here for a 90% confidence level. That would be 1.645. For 95%, that would be 1.960. And for 99%, this would be 2.575. You can also find these confidence levels here, or these critical values, excuse me, at the bottom of table 7 in the back of the textbook. So if you look on the e-text there, if you go to the appendix and you look up table 7, you will be able to find these same values here. Let's see if I can find it on the textbook. I actually don't want to lose my place in the textbook. The e-text shows here. Let me switch to the main cam here real fast. All right, so in the back of your on the back of your textbook here, you'll see this table here, and I'm gonna kind of show it up on the screen here. So this is the table 7. This is what it will look like. All right, in your appendix. I know I'm bad with cam, but it'll be right at the bottom, the very bottom there. The very last row of numbers is where you're gonna find those critical values. And we're not gonna use it too much, but again, it's there. So again, it can be used every once in a while. All right, sorry about that, Alyssa. I'm gonna go back to the first one here. Okay. So let's see if we can find the necessary sample size in a given circumstance here. So let's go back to our big board here. There we go. And let's get the book here. I'll move this over to the right. Okay, so let's look at number 39. All right, so let's look at 39 here together. And we'll see exactly what we get here. All right, so let's look at 39. A TV sports commentator wants to estimate the proportion of Americans who follow professional football. What sample size should be obtained if he wants to be within 3 percentage points with a 95% confidence if A, he uses a 2010 estimate of 53% obtained from a Harris poll. All right. So in this particular case, what we want to do here is we have a point estimate here. We have a P. So he's using a previous result. So this particular commentator is using a previous result to see exactly what that sample size would be to match that particular result. So let's see how we can do that here. This 39. All right. So for P here is equal to, again, 0.53. We're given a point estimate here of which to start with. All right. And here we're given we want, this particular commentator would like a specific margin of error here to be 3%. So our margin of error here will be 0.03 to reflect 3%. Don't forget, you do need to use the decimal here. Okay, and let's see, what else did they give us here for this problem? They would like a 95% confidence. Okay, so our confidence level here must be 95%. All right. That's fine. Okay, so let's use the formula here. All right, and then we're just going to see exactly what this sample size should be here. All right, so we're going to plug in our numbers here. We'll plug in 0.53 times 1 minus 0.53. All right, and then we'll multiply that by our critical value here. Now, our critical value here is based on the confidence level that we're given here. In this case, 95%. So again, just a friendly reminder here, this is why we have this little chart down here. 95%'s critical value associated with it is 1.96. So 1.96 is going to be our guy. That's the critical value here. So again, just make note of that. And then we'll divide that by the margin of error here, which is 0.03, and we will square that. All right. Let's plug this into the calculator, and let's see what we get. All right. So let's do 0.53 times 1 minus 0.53. And then we'll multiply that by 1.960 divided by 0.03, and then we will square that. We could just put it in just like so on the calculator here, and we'll go ahead and enter. All right, so in this instance, we get this answer here, 1063.2.3. Now, you notice what I'm about to do here. Now, obviously, we can't ask 0.3 of a person. That doesn't make any sense. So, just as a side note here for all of you guys, remember that we're going to always round up. Okay? Round up, no matter what. Because we don't want to round down. We want to ask enough people in order to satisfy this requirement here. So, we're going to go up here to 1064. Okay, that's going to be our final answer for this problem. So don't forget to round up. That's very important. Okay, so that's why I was a little bit looser with the decimal points for that problem there. Any questions about that? Okay, now the other half of the question here, there is a part B, or part, I forget, it's part B or part C. Anyway, let's do it anyway. Alright. So, yeah, let's do part B. Part B, he does not use any prior estimates. So let's say we're not basing it off of any study. Alright, let's say we have no study whatsoever. Alright, and we would just want to see exactly how many people we should ask in order to get proper results. So again, this is with no study or P. Okay. So if there's no study or P here, go down to our second case. This is our second case here. Then essentially at the end of the day, we're just gonna kind of cut it halfway through. We'll use our second formula here instead. So we're gonna use 0.25, and we are gonna use the same numbers here as we have from before. So again, we still have the 95% confidence level, so we're still gonna use the same critical value here of 1.96. So that doesn't change. And then we still want the same margin of error here. We still want 3% margin of error here. So maybe that's our personal expectation here in this problem, and that's fine. All right, so let's plug this in here. So we get 0.25 times 1.96 divided by 0.03 squared. And let's see what we get here. Alright, so here in this case, this happens to be 1067.1, or again, in this instance, 1068. Okay. And there we go. We got our final answer for that problem. Alright, any questions about that? Hopefully that was pretty straightforward. Want to be sure everybody sees that. It's not bad. Okay, it takes a little time, but once you understand what kind of info you got, fine. Now I understand that these values here look really close, 1064 and 1068. The only reason why they're super close is because of the fact that 0.53 is close to 0.5. Alright, that's where you get the 0.25 is if you multiply 50% times another 50%, you get 0.25. So 53% being close to 50% is why we get pretty close figures. But if this was like 70%, yeah, then these figures are not even remotely close. So, just depends. Alright. Okay. So that is, in effect, that is, in a nutshell, section 9.1. Okay. We're going to move down here to section 9.2. That is what's on the agenda here for this next part. So let's do that. So we'll spend the rest of the class here doing 9.2. Okay, so in section 9.2, we're going to be dealing with a new type of distribution, okay? And this distribution here will appear once again a little bit later on in the textbook. I believe the next chapter or the chapter after. Actually, another couple times here. So this next type of distribution is an important type of distribution that we look for here as well that has slightly different properties than that of the normal distribution. And that's what we call a T distribution, or the book likes to call it the student's T distribution. In any case, regardless of whatever you call it here, it is a different type of distribution. Now, let's talk about what is a T distribution here. This is a type of distribution that closely resembles a normal distribution, so close to that bell-shaped curve. But this also includes one caveat. That caveat is this includes the what we call n-1 degrees of freedom, with the population standard deviation being unknown. But one of the things in statistics that we try to do is sometimes we're just not given enough information. How do we start filling in the gaps? Well, we can basically make a few assumptions here if we hopefully make it fit correctly. Alright? And we have to make sure it's kind of set up that way. Alright. So, the population standard deviation being unknown here, but we will talk about these degrees of freedom here, these n-1 degrees of freedom. Discuss about that. So, what does it look like here? If we go to the textbook here, it kind of, like it says, it looks really similar to that of a normal distribution. See if they, I know they put a picture here in the book. Maybe that was the picture. Yeah, so it looks something akin to a normal distribution. So it looks pretty much like one, but it's not exactly one. All right. In any case, like here we go. This is the picture. So it looks like a slightly looks like a slightly like more flattened normal distribution. Anyway, I digress. All right. Let's talk about the properties, though. Let's go to number 2. All right, number 2. What are some properties of a T distribution? All right. First of all, a T distribution is different for different degrees of freedoms. So how flat it is dependent on how many degrees of freedom that T distribution is going to be. So you're like, it looks normal, but again, it's going to have different shapes based on the sample size. We'll talk about that here in a second. The T distribution is centered, instead of the mean, like a normal distribution where we center it at the mean and then cut it in half. Instead, this is actually centered at specifically 0. Okay, so an actual value here of 0, and it's symmetric about 0, much like the normal distribution is symmetric about the mean, 50-50 split. It's symmetric about 0 here, so cut it right down the middle at 0. One thing that holds true is that the area underneath the curve is 1, or 100%, just like any other probability distribution curve. Fine. And as you increase the sample size, n, the density curve of T, so that T distribution gets closer to the normal density curve. So if we increase the sample size n here, let's say we go from 100 to 1,000, okay, then it's going to look closer and closer to an actual normal density curve. So it'll actually look like a normal distribution the higher we get here in our sample size. So ideally it'll make it there, but it doesn't look exactly like it at the very initial outset. Now, what are these degrees of freedom here? Oh my goodness, made you mad. Subscribe for 13 months, my dude. My dude, 13 months. Oh man, how you been, made you mad? Jeez. Thanks for subbing, my friend. I'm good. I'm good. Good to see you again, by the way. It's been a little bit of time. Why you keep subbing to me, I'm still not sure, but thanks, my friend. I really appreciate it. I still don't understand to this day. I'm like, okay, man. I'm like, I'm just a dude teaching math. I'm like, alright. Okay. What you been up to the past month, by the way, Major Man? I gotta ask. Alright, while you're figuring out an answer for that, let me put this down here. Alright, so, how many degrees of freedom are there for a T distribution? Well, the number of degrees of freedom here is going to be dependent on the sample size. That's why I say n minus 1 degrees of freedom, because we take the sample size and we subtract by 1. Block 2 at is that Wilmington? Is that what WILM stands for? Okay. What does block 2 mean? I'm not sure what block 2 means. You'll have to explain that one to me. Oh, so how many blocks do you have in a given academic year? That's pretty interesting. Seven weeks is pretty short. I ain't gonna lie. 2 blocks per semester? Okay. But they include oh, right. I gotcha. So you do 4 blocks per year then. Alright. That makes sense. I didn't know how things are. The schools are. Every school district is different how they do things. So. I don't know if I could. I mean, I've taught classes that are 8 weeks long. But they can be very overwhelming, so you have to be careful about that. At least sometimes I think that way sometimes. So for some students, it could be really overwhelming of getting things done in 7 weeks. So gotta be careful. All right, how many degrees of freedom are there in T distribution? As I said here, the sample size subtracted by 1. All right. How do we find a critical value for a t-distribution? Well, we can use the table in the back of the book. This doesn't use, by the way, this is if we do it the manual way. I'm going to show you how to do it, of course, the calculator way. But this is using the manual way is if we use this table that I showed you earlier here in class from the back of the book to determine a manual value. However, the back of the book is only a limited amount of values. That's why I say is it does not contain all critical values for all degrees of freedom. Again, you only have a limited amount of print space. You're only going to have a limited amount of values. Yeah, I once took a 6-week course and it was pretty rough. I ain't gonna lie. All right. Okay, let's talk about a confidence interval here. Let's do some confidence intervals, ladies and gentlemen. Well, we're gonna do an actual problems here, but I just need to at least state this here. All right. How do we construct a confidence interval for the mean when the population standard deviation is unknown? So, to understand what's going on here, okay, I want you to take note here. One thing here very important is that the population standard deviation here is unknown. All right, it's very unknown. All right, so we don't know what the population standard deviation is. Now, why is that important here? Well, it's because in the formula here, for us to actually go ahead and find this this particular confidence interval, we actually are going to use S. Now, if you recall S here, S is the sample standard deviation. All right, so we're not using the population standard deviation, we're using the sample standard deviation. Now, specifically on the calculator, what are we using? We're using what's called the t-interval. We'll show off what that looks like on the calculator in just a moment. Using appropriate values such as data or stats and the confidence level. And we do need to show that off too. There's a lot kind of going on here for this particular section, as it has quite a little bit of a different look than maybe the last one. Okay. If you want to find the margin of error, we have t of alpha over 2, which is the same thing as the critical value, times the sample standard deviation divided by the square root of the sample size. That is going to be your margin of error. Okay. Let us do an example here. Okay. Example is shown off on the bottom, but anyway. By the way, Major Man, if you're still there, how are things going at Wilmington, by the way? Hopefully you haven't had too much of a problem. Okay. All right, let's look at the number 28 here. All right, let's look at 28. So let's read this off here together, and then we're going to work through this together here as well. All right, hungry or thirsty? How much time do Americans spend eating or drinking? All right. Suppose for a random sample of 1001 Americans aged 15 or older, the mean amount of time spent eating or drinking per day is 1.22 hours with a standard deviation of 0.65 hours. Okay. We're going to do letter C here. All right, we're going to do letter C. And we'll also answer letter D there, but C is the primary one here. All right, determine and interpret a 95% confidence interval for the mean amount of time Americans age 15 or older spend eating and drinking each day. So let's first write down our couple of things here. First of all, we have our mean here. Our mean here is given to us as 1.22. Our sample standard deviation here, again, remember this is from the people that we asked here. So this is why it's a sample standard deviation and not everybody. So is 0.65. And then our sample size here is going to be 1001. So let's get our confidence level here. Oh yeah, we also need a confidence level here. Our confidence level here will be 95%, so it'll be 0.95 to reflect that. Okay. Hydrate, Yusuf says. Yes, sir. Thank you, sir. All right. Okay, so let's go ahead and put this here together. All right. All right. I hope everybody has their calculator out. All right, as we're going to do this here together on the La Calculadora. All right, so we're going to use a function called t interval here. So I want you to hit the stat key here. Go over to tests, okay? And then I would like you to go down specifically here to number 8 that says t interval. Okay. Put that in the chat there. Go. So stat, tests, and then number 8, which says t interval here. Okay. All right. Now, please type in the chat yes if you are at this submenu. Old school, new school calculators, it doesn't matter. You should see this. You should see the submenu. Okay. All right. So hopefully everybody is at this submenu here. We want to make sure that we're all on the same page because I'm gonna do a couple of things here next. Okay. So I don't want to change anything yet. Okay. Now I'm confident that all of you here are at the submenu. So, okay, planets there. Okay, good. All right. So what I'm going to do next is, as you can see at the very top, you have two options. You have data and you have stats. Okay. Now in a problem like this, okay, where we are given a mean, we're given a sample mean, we're given a sample standard deviation, we're given a sample size and a confidence level. What I would like you to do is I would like all of you here to go over to stats and then hit enter. So go to stats. That's that second option there, and then hit enter. And then that submenu will change, okay? That submenu will change to this one, okay, that you see here on screen, all right? Now, once that submenu changes, we're going to go ahead and now plug in our values that were given here. So if you see, the first thing that we see here at the very top is going to be our sample mean. So that's going to be where our 1.22 is going to go in. We have SX here, which is the same thing as our sample standard deviation. Again, our notation here. So that's going to be 0.65. Our sample size here was 1,001 people. Okay. And then finally, we're given our confidence level here of 0.95 for 95%. And then we'll go ahead and hit calculate. So we should have here 1.1797 and 1.2603. All right, type got it in the chat if you have this on your screen right now. Want to make sure everybody got these values here. Type got it in the chat if you have what you see here on screen. Okay. See if Planet has it. Anybody else having issues or anything like that? Hopefully everybody's okay. All right, Planet got it. All right, cool. All right. Okay, now we went ahead and found the confidence interval here. All right, so that's good. We went ahead and found the confidence interval here. Now, the more important part of what's going to happen here is that we want to be able to interpret this confidence interval. Remember, you're going to be asked two parts here. You're not only going to be asked this confidence interval, but you also are going to be asked what does it mean. All right, what exactly does this confidence interval mean? All right, so the interpretation of said confidence interval. So let's go ahead and take a look at the context here. Again, this was talking about the amount of time spent eating and drinking together, combined. So if we look at the, actually, I need to look at the handout. Pardon me. Let's look at the interpretation. This is something that we need to talk about here. It says, all right, we are 95% confident that the mean time of all Americans. Okay, so the key words here, I want to point this out here and make sure that you have this written down and underlined here. Is that the mean time of all Americans? So again, we're just taking it from our sample of 1001 and now extrapolating that to all of Americans in the population. So all Americans 15 plus spent eating and drinking is between 1.1797 and 1.2603 hours. Okay, that's the interpretation that we have here at the end of the day. Okay, so I want to talk about that here, at least what that means overall in terms of the aspect of this particular problem. Okay, are there any questions so far about that? Again, just like the last section, 9.1, we have to talk about an interpretation. In this section here, 9.2, we also talk about an interpretation of that confidence interval as well. So make sure you note that, so that way you're aware that you're going to be asked those questions there on the homework. So, and on the test. So. Any questions so far about that? Okay. All right. So we have that. Very good. All right. Let's take a look at another one here. Actually, I need to do one more part here for this, actually. So you may get a question like this on the homework, just in case, just to kind of cover our bases here. Let's look at letter D. Letter D asks, could the interval be used to estimate the mean amount of time a 9-year-old American spends eating and drinking each day? So if you see a question like letter D, it says, you know, could you use this to estimate for a 9-year-old? The answer is no. Okay, you cannot use this interval here because the context of this interval is only for people who are 15 years and up. So this is only for 15 years and up. So okay, so that's why, again, if you're trying to, it's like saying, okay, what applies for a 15-year-old should apply to a 9-year-old. That doesn't make sense. Okay, if that study is only done for 15-year-olds, 15 plus. So again, that's why for part D, if you see a question like that, the answer is absolutely not. All right. Okay. Let's do another one here. All right. So the next one we're going to do here is going to be number 33. All right, so let's do 33 here. All right, so crash test results. The following data represents the repair cost for low-impact collisions in a simple random sample of mini and micro vehicles such as the Chevy Aveo or the Mini Cooper. I totally forgot what a Chevy Aveo was. And I think the Chevy Aveo, I know they stopped production of these vehicles a long time ago. At least I think they have. Maybe they actually still produce them. Oh no, they ended it last year. Okay. Now if you want to know, the Chevy Aveo looks like this. Okay, so that were these really super small subcompact cars. Almost looks like a Prius. Although I will have to say the Prius has a lot better gas mileage than 27 and 35. Oof, that's brutal. Alright. Anyway, I digress. Alright. Alright, so we have this data here for cost of these low impact collisions. So we have various dollar amounts. Alright. So let's take a look here at letter C. Letter C says, construct and interpret a 95% confidence interval for the population mean cost of repair for these vehicles. Alright, so that's what we're going to do here. We're going to have a 95% confidence level for this. Alright. Now, in order for us to actually do this properly here, we're going to go ahead and use the calculator for this. So let's follow along here with the calculator. I'm going to kind of move this over here for just a second to the right. Okay, and then we'll use our calculator here to the left, as we do need to reference these numbers here that are on for this particular problem. So, what do we do for this problem here? Alright, so let's follow along here very carefully. We'll go ahead and see what our confidence interval here is going to be for this guy. So what I would like you to do here first and foremost is to go ahead and hit the stat key here. Yes, but we need to set it up before we do that first, okay, Sneaky? Alright, so we're going to go ahead and hit the stat key here. But you're not wrong, Sneaky. But we need to set it... We need to get the calculator prepped before we do the data part. So, we hit the stat key. We want to go to edit. We want to go to edit. Now, if you have values here in your thing, again, highlight it, hit clear and enter to clear out your lists. That's perfectly fine. Okay? And so for list 1, and only list 1, we're going to go ahead and type in 3148. And the other numbers, 1758, 1071, and all the numbers that we see here on the screen for this problem. Okay, so we should have 10 values here. Now, before I move forward with this, I want to be sure everybody's got all the correct numbers in here. So, type done in the chat once you have all your numbers in your list. Again, they should match the numbers that you see here on screen. So, be sure to enter them in correctly. Got it? Okay. Hit done. Good. Alright, Carla's done. Good. Done. Vince is done. Good. No, sometimes it takes a little time getting all these numbers entered in, so... Alyssa, Planet. Alyssa's done, okay. Just saw yours, Alyssa, just a second ago. See if Planet has hers. Alright. I know Planet's a little bit behind in that thing. So. And hopefully everybody else got it here. Well, it could be Planet step delay, I'm not sure. Alright. In any case, alright, so if you have all your numbers entered in here. Alright, if you have all your numbers entered in. Okay, good, Planet. Alright, good. Got it. Alright. So, Planet, are you on the delay? Actually, I should ask that. All right. So once you go ahead and excuse me, once you go ahead and do that, we're gonna hit second in mode. We'll quit to the main screen here. We're gonna go back. We're gonna hit the stat key here. We'll go over to tests. We're gonna go down to number 8, which is T interval. We'll do the same thing here once again. Okay. This time, however, once we get back to this little submenu here, all right, we're gonna go ahead and scroll over to data. Okay, so I want you to go over to data here on your calculator and hit enter. Okay, so we're gonna go over to data and hit enter here. Now, underneath data, if you don't have anything over here, though probably it defaults to list 1, but let's say it did not have anything in here. All right, so if it's blank, then you want to oh, okay, that's fair. All right, so if it's data here, then again we want to bring up our first list here, so second and 1 for list 1 if you don't have anything entered in there. I'm in my phone, so okay. No, that's totally understandable, Clay. Totally understandable. Frequency, this is a number we're not going to touch. We're not going to touch this number here. Leave this as 1, okay? Just leave it alone, all right? And then the confidence level here will be 95%, at least this is the case, 0.95. Again, if it's a different value, let's say 99, you would put 0.99 here. I think you get the general gist. All right, and then we go to calculate here. All right, and here we go. We have our confidence interval. So let's go back to our paint tool here. Our confidence interval here is going to be specifically 1035.8 and 2477.2. All right, so this is going to be our confidence interval here. So from 1035.80 to 2477.20 would be that cost. Now, once again, let's talk about this here one more time. Remember that we have the confidence interval, but don't forget, you do have to also do the interpretation behind said confidence interval. So let's not forget about that. Interpretation here is just as important as the calculation here. So if we do the interpretation, we go back to our handout here, for example. You're fine, Overspeed, my friend. It's good to see you. I hope you're doing well, my man. I hope you've been well, Overspeed. All right. So, what would we say here in this case in terms of a confidence level? We could say we are 95% confident, again, because of a 95% confidence level. We are 95% confident that the mean cost of all mini and micro vehicles in low impact collisions is between 1,035.80 and 2,477.20. So based on the data here, this is the mean cost for all mini and micro vehicles. We take our sample of 10, apply that to the entirety of all mini and micro vehicles, and this is the conclusion that we come up with after everything is said and done. Okay, so don't forget, it always goes to all for that particular mean, the mean of all. All right. Any questions about that? You're in uni the last time you were here? Wonderful. If very good, very good. I don't know if you're taking any math classes, Overspeed, but if you are, then okay, you can certainly ask me for help. But if not, that's fine too. I totally understand that too. Some people want to avoid math like the plague. But I don't blame you. All right. Oh, you're taking. Oh, so you're taking this class. Okay, got it. So Overspeed, you're taking exactly this class. That's exactly what I'm doing here. I'm doing statistics and probability. Even though I'm teaching it in English and you're doing it in Arabic, it's the same. It's the same thing here. You got to admit, hey, how you doing, Jamie? You got to admit, yes, 4 goals in a match. You basically outscored an entire team. You gotta admit, Daka was on point yesterday. Absolutely crushed it. Absolutely destroyed. 4 goals, man. Holy smokes. All right. Let me see if there was anything to talk about here. All right. All right. Let's look at this last one. You may be asked this question here, so just to let you know, this could be one of those questions you may see. Um, gotcha. I love you too, Jamie. um, suppose you obtain Ronaldo won the game. That's all you need to know. Ronaldo won. Ronaldo won. Look, Ronaldo saved United. That's all you need to say. You can say that. But Ronaldo, look, say what you want about Ronaldo, but he saved United so far. And Ole Gunnar Solskjaer's job. So all I need to say is got pocketed by You think Messi is the best player on the planet? No, it's Ronaldo, my man. I'm sorry. I'm gonna have to disagree with you there. Ronaldo, by far and away, is the better player of the two, if you were to compare. Don't matter if you feel like you didn't touch the ball, I got credit for it. Alright, letter D. Suppose you obtain a simple random sample of size n equals 10 of a Mini Cooper that was in a low impact collision and determine the cost of repair. You think the 95% confidence interval will be wider or narrower? Okay. Nah. Now, if you were to just use a Mini Cooper instead of just the Chevy Aveo, let's say you were doing one car. In this case, from the perspective of this particular example here, the actual thing is this would be much more narrower, okay? Because you're only using one car here to actually get a full fleet of vehicles. Okay, but look, I'm gonna say this, Jamie. All right, you're in a statistics class, all right? I'm going to point this out here. A sample size of one game doesn't tell you the full breadth of the individual over a lifetime of achievement. I'm just going to point that out there. It's like saying, "Oh, he didn't do anything one game, so he's just absolutely garbage." Like, get out of here. All right? Don't even tell me that. Small sample size that can't be extrapolated to the entire career of an individual. It's ridiculous. Everybody always uses anecdotal evidence. I'm said don't come up with me with anecdotal evidence that doesn't tell you a broad conclusion. So he beat him, and he won, and they won. That's it. That's what you have to accept. You have to accept. You have to accept United won. All right, whether you like it or not. Where's the score sheet say? Score sheet says they won by a goal. That's it. That's how it works in sports. It's winners and losers. When it comes to these matches, anyway, there's winners and losers. You know, somebody's got to win. I'm talking about the 3-2 victory, unless I'm looking... Oh, you're talking about, like, if you're talking about the 4-2 in the Prem, I'm not talking about the Prem, I'm talking about the match yesterday. If you're talking about the 4-2, Premier League loss, yeah, then I saw that match, If you're talking about Leicester, yeah, okay. Ronaldo didn't do anything that match, but I'm telling you, Ronaldo, the player, doesn't reflect in one match. I'm going to also point this out, one thing, Jamie. The Premier League has 38 matches a year. So just because you don't do well in one match doesn't mean you're absolute dog water. Okay? I'm just going to be honest with you here. If you show consistently that you're dog water, then yes. Okay, I can make that conclusion. But Ronaldo throughout his career has not been dog water. Okay? That's what I will say. Absolutely. 38 matches a year. I will tell you what's... You want to know how Americans think? Alright, I'll tell you how Americans think, Jamie. You have 38 matches in the Prem. You have 17 games in the NFL. When one player does bad in the NFL, yes, you think from week to week, you think that they're hot garbage. Alright? Absolutely true in the NFL. Because there are fewer games and you have you have a less of a margin of error. When you have 38 games, there's a higher margin of error. Okay? When you have, let's say in baseball, you have 162 games a year, there's a very large margin of error. I'm gonna be out to see. Look, that's the thing if you're trying to be objective when it comes to sports. Okay? So you check to come to sports. So just like we say here, the higher the confidence level, ladies and gentlemen, the larger the confidence interval is going to be at the end of the day. Name a more overrated player than Jadon Sancho. It's a good one. What was his name? Not, no. How about Jack Wilshere? How about Jack Wilshere? There you go. Thanks, Sneaky. It's true. That's how people come up with the conclusions. They only look at one game. They're like, oh, he's complete garbage. I'm like, oh my gosh. How about Jack Wilshere? Well, Jack Wilshere was, you know... Yeah, but look! Completely overrated. Best thing since sliced bread? Then... wasn't heard from again. Okay? How about Tammy Abraham? You could say Tammy Abraham's overrated. Sancho isn't injured every other week. My friend, statistics run the world. Statistics run the world. I ain't gonna be honest with you. You just didn't get a chance. A lot of players don't get a chance. Let me be honest with you. Some players are great, and they just never get a chance. It's true. I will say that statistics literally run the world. Like, think about so Sneaky. If you're talking about the current Moneyball in all of the Premier League, and this is the case that actually is intriguing me right now, which is why I'm supporting them right now. Is if there's going to be a team that will actually change the entire face of football and entire taste of soccer. All right, if we look at it from a big picture perspective, then the only team you need to look at is Brentford. Okay, if you look at Brentford here, Brentford, by far and away, will probably in the long term, probably revolutionize the face of football. All right. Now, I don't mean that actually in terms of the bigger teams that are, like, say, in the English Premier League. For, like, your Newcastles or your Manchester Cities or your Manchester Uniteds, it probably won't move the needle too much. Um, is that Blackboard? Let's just Google. I just made it dark. I just made it dark mode. So it's dark mode. It's dark mode to Google. Uh, so uh, yes, yes, Overspeed. That's correct. I I work at Overspeed. I work at two colleges, so I work one of my colleges. I use Blackboard. So all right. But if you look at Brentford here, Brentford is an entire team based off of a, say, statistical analysis and a lot of scouting, a lot of scouting. So I mean, they run from a principle of always trying to get talent that's underrated, that there's overlooked, and they got them for cheap, they build them up, and then they sell them for much more than what they're worth, and they turn a profit literally every year. Is Leicester? Leicester has a bigger backer. So that's the thing is, if you're talking about a small, so I guess the way to kind of put this, Jamie, is if I were to relate it to Major League Baseball, Leicester is still in the kind of the upper echelon in terms of how much they spend. Okay, Mahrez and Conte and Didi, no, Jamie. What you're looking at is, again, anecdotal evidence. You need to look at consistency. Brentford consistently promotes players, and then they automatically will sell them for a profit to other clubs who will be willing to pay a premium for that. Okay? Like I said, Jamie, the problem with your argument is it's one player compared to many. Brentford has done this many, many times over the years and has turned consistent profits. The issue with a lot of clubs is that usually they're running a loss. Their bank books don't look as bad as, say, Barcelona's, of, like, let's say, being in the red, nearly €1 billion. But at the end of the day, Brentford always is going to turn a profit, even if that player is really, really good, like a Mahrez or a Conte. Okay, those players are excellent and very, very good. But really, you're looking at consistent success while at the same time not breaking your bank book in order to maintain that particular roster, which I feel a lot of teams at the top of the league end up doing, is that they spend billions and billions of pounds on particular players to build the best roster possible, but then they look at the balance sheet and they're like, wow, the balance sheet is really awful. All right, unless they have backings like you have your Newcastles or your Manchester Cities or your Manchester Uniteds, you're really not going to find that situation in a lot of English clubs today. In fact, most of the pyramid here is running on a shoestring budget as opposed to running on major budgets, and that's not where people need to be looking at, to be perfectly honest here. So when you look at things like Brentford is an absolutely Moneyball type of club. And again, Moneyball revolutionized baseball, where it says, I don't need to necessarily have the most expensive players in order to be the best team on the block. All right? Money doesn't necessarily equivocate success, okay? It doesn't equivocate better outcome. All right? If I'm going to turn a profit, which is what an English club is after, then what I'm really looking for is how can I actually consistently do that over a period of time. Okay, and that's what Brentford has done. And really smartly, the owner of Brentford has actually put himself in a very, very interesting position in terms of what he owns. He owns like two teams. He owns Brentford, and he also owns a Danish team called FC Midtjylland. He basically can run two professional teams at the same time and bring together the best of the two parts, essentially run an excellent club, and raise the value both at the same time. Yes. Letter D here, Vince. Sorry. Apologies about that. Letter D here is if you have a Mini Cooper, right? So let's go back to this example here. If you have just Mini Coopers, the answer will be narrower. So think of it this way, Vince. If I were to only have Mini Coopers and I were only to check the amount of repairs for Mini Coopers, well then wouldn't they be hovering right around the same price? Because of the fact that you're only looking at one type of car. correct? So if I'm looking at many different types of cars, well then yes, that value is going to be kind of all over the place, Vince. But if I only look at one type of car, then it's going to be much, much narrower. Again, Jamie, that's a flash in the pan. Just gonna say, that was an outlier compared to what the rest of the league has been around that period of time. It was by far and away, Jamie, a miracle season. Yes. Sorry, I get caught up in actually talking about football these days because I'm like been doing some research behind it. All right. Are there any questions over section 9.2? Let me at least say that. Yes. 9.2 would be the up to the homework there. But Vince, have you done the test there or the homework for chapters 5 through 8? I hope you have. So if you've done that, then go ahead and focus on 9.2. But if not, focus on the test, okay? I know Jamie has plenty of questions about football, that's true. Okay, Vince, so focus on doing the practice test here first, and then do the test. Because you have several chances, so you can certainly improve your score if you're not very happy. And then you can go ahead and focus on Chapter 9. Just, one at a time, my friend. Always. Yeah, I just want you to focus your eyes on the prize. Let's not forget about the test. I don't want you to wait till the last minute, Vince. We don't want that to happen, alright? You do pretty well when you have enough time to digest everything. My maths career is over. Alright, everybody. We could do some discussion here afterwards. I don't got a problem with that. If there are no more questions over math anyway, we will end off here with the lecture for today. We're going to do the latter half of Chapter 9 here for next week, so there's still a couple more sections here in Chapter 9, 9.3, and 9.4. So we'll finish that off here for next time, all right? But in the meantime, everybody who's in my maths class anyway, I hope all of you have an absolutely wonderful weekend. All right? Please take care of yourself, all right? Again, everybody, I wish you the same three things as I wish you all every time. Again, stay safe, stay healthy, but most importantly, stay sane. Again, you guys know where to contact me. I'm on Discord or on email, so please feel free to contact me if you need to talk or ask questions. I'll be more than happy to take those on. And remember, I'll be sending out an email here this weekend, by the way, also to give you a reminder that the test is due on the 2nd of November. Okay, so remember that test and the homework there for chapters 5 to 8 is due 2nd of November. So I'll send out an email this weekend in regards to that, so we'll give you a friendly heads up in regards to making sure that you get that done ahead of time. All right, everybody, have yourself an absolutely great one here. All right, I'm going to stick around here for just a little bit, and have a great weekend. All right, take care, everybody. We'll see you later. All right. All right, I'm here to talk football now. I'm here in I'm here in football mood now. Now that Jamie's got me talking about football is what he's got me doing. Let me be honest with you. Your maths career is over. You got a 5 and moved on. Let me tell you, whether you like it or not, Jamie, maths is what makes the world go round. Okay, that's the reality of the situation, Jamie. Maths makes the world go round. Maths controls football. That's how it works. All right. Let's not forget that VAR is run off of maths. All right, my dude. A lot of things revolve around the idea of maths. I'm telling you right now. You can never underestimate the idea of maths and how it affects you on a day-to-day. Say what you want. All right. Don't care if you think it's shit. But I will tell you this: it's a necessary part of the It's a necessary part of the game, 100%. Necessary part of the game. You may hate VAR, you may hate the millimeters of offsides. We may all hate that. Understandable. But if you're gonna be consistent with the rules, then having VAR is much, much better. That's very true. It's pointless. Oh, wait. So suddenly it's England, it's terrible, but everywhere else it's perfectly fine. It's not consistent, though. I tend to disagree with that. I disagree with that. Some people will say, there's always a margin of error in a VAR, but I will say that I think it's been pretty much on the ball. I think it's been pretty much on the ball. The only time people get upset is when it doesn't go your way. When you're a supporter and it doesn't go your way, well then you get upset because it doesn't go your way. That's fine. When it goes your way, perfect. When it doesn't go your way, then you're up in arms about it. Like I get that. That's just part of being a supporter. VAR has been, in my opinion, and I know this is an unpopular opinion, but VAR has been a very big blessing to football, to the world of football. And I know that's a very unpopular opinion. Okay, a very unpopular opinion to some people. But to football, it's been a blessing because it removes a lot of the controversy behind each match, right? It removes a lot of that controversy that was before in each match. If there was, for example, like handing out red cards. Handing out red cards is now reviewable by VAR, and you had controversies before. You had controversies before where you're handing for maybe possible touch fouls in the box. I think it's done an absolutely fantastic job. I think it's been consistent across the board. I think it reduces the amount of rigging that could occur in matches. I think it provides video evidence about what you're seeing, in terms of what's going on in the game. I think it's done a fine job. And the Prem, it's wank and inconsistent. No, I don't think so. I think it's been fine. I think it's been consistent. I think it's okay. Look, it's taken away goals. It's given goals. It's taken away goals. It's given penalties. It's taken away penalties. At the end of the day, yes, it could negatively affect more teams than others, but that's just the way cards can fall at the end of the day. That's just the probability of the situation at hand. That's just what happens. That's just random chance. Just like any probability in statistics, it's just random chance. If I were to criticize something, like if I were to criticize replay, I could criticize, for example, I could criticize replay in the NFL. Replay in the NFL is not good. Okay, replay in the NFL is pretty terrible. All right, because I believe that replay in the NFL should be able to cover more than what it's currently covering. All right, it doesn't cover like personal fouls. It doesn't cover other things that actually occur on the field. And I think personal fouls, I think flags, like penalty flags in the NFL are pretty inconsistent across the board. I think that's something that you certainly would have to correct, and I think that you could have video replay to hopefully correct those actions a little bit. So it could give something next week. And look, some decisions, Jamie, like the NFL. I'm gonna be honest with you. One thing that I will say about why I like the NFL replay and why it's not expanded enough is because there are some plays that are so close that either you take the call on the field or you can reverse it. Now, the way the NFL structures the way they do that in the NFL is they do it like this. They're like, okay, if you have, no, not at all. Actually, it's a fair system. Here's how it works, right? In the NFL, they make a call on the field. The referees make a call on the field. They say it's a catch or whatever, it's a fumble, whatever. Okay? They make a call on the field. Then they turn to the video assistant. They say, okay, was that the correct call, yes or no? If there's enough evidence to show that that's the correct call on the field, to show that that's not the correct call on the field, they'll reverse their decision and it'll go back to whatever it was before. If there's enough evidence to show. So you have to show that there's a clear and enough evidence in the replay to actually show it. Otherwise, you have to use the referee's decision at the end of the day. Essentially, it is a true 50-50 call, but you do look over it and you do pore over the details to see exactly what the conclusion can be. Some things that the human eye can't catch is what replay can catch here. So I don't feel that in that regard, in that particular perspective, I don't feel that it's inconsistent. I feel that in actuality, you're going to get a 50-50 call anyway. You're going to see if there's any evidence to overturn the decision that was made on the field. And if not, then okay, you keep it as is because the 50-50 call is going to go one way. Okay? If there is, then the 50-50 call is going to be reversed, and then you get that decision, based on what you see there on the field at the, what you see in the replay. Okay. Is some people going to like it? Yeah. Is some people going to hate it? Yeah. But that's what happens with any 50-50 call. It's going to be so minutely close that there's no way of telling here, even by the human trained eye, or maybe even by replay, that would be the correct call in that given situation. Don't forget, Jamie, one of the things you cannot forget is that things that happen in real life can't have, things in FIFA, for example, that can't be modeled in real life. A 50-50 situation can't be modeled exactly like a video game. So in real life and a video game, two completely different things where you're going to get the exact correct calls possibly in a video game compared to, like, say, real life, where it's not always going to go exactly that way because you don't know what's going to go on 100% of the time. That's just natural. We accept this in maths. In maths, we accept that you're not always going to get 100% probability. So you're not always going to be 100% correct. These are cases where it certainly falls within that set of conditions. You'll never get purely 100%, but if you can come close, that's perfectly fine. It's the same thing with umpires in Major League Baseball. Okay, they're not going to get every call correct. That's just how it is. But for like balls and strikes. But if you have a 98% accuracy, then that's pretty darn good for the human eye. Although they're trying to actually get it to be 100% by instituting a automated ball and strike zone, but some umpires, I will admit, are absolutely terrible. So I ain't gonna lie about that. You guys are free to ask me any question that you want here, so if you'd like to make a comment or make any or if you'd like to ask me a question, please feel free to do so. Okay, yes. Computer. Alright. Show me the same icon 15 times. Alright. Nothing? Alright. That's fine. Alright. Alright. I'm gonna go ahead and raid another channel here. And let's see if there's any channels that I can raid here. I'll just raid this channel here, and we'll be fine. Alright. I hope everybody has an absolutely fantastic day. We will see you all later. Take care, everyone. Have a great one. We'll see ya in a few hours, actually. I'll be on for another class.